Salam Doctor, I'm SIAH and today I'm going to demo my lab 2. So in this lab 2, we're using half wave and full wave converter. And how can we determine whether it's a full wave or half wave? So we can actually distinguish it by looking at the circuit and find how many SCR the circuit is using. So for example, if full wave converter, we will have 4 SCR inside. If half wave converter, we will have only 1 SCR inside. Why? Because full wave converter is meant to convert the negative part of the cycle of the signal into positive part. So we can only convert it with the help of 4 SCR. So let us run a simulation and observe the output. So as doctor can see that this is the input, which is the source, and this is the load, which is the output. So when we're looking at the source, it is a normal sinusoidal signal, right? And for the output, we can observe that the negative part of the source is deflected into positive part. Yeah, so the negative part right here is deflected into positive part right here. So it means the 4 SCR converted the negative cycle of the signal into positive part. So what is the difference at the half wave one? So wait for a second. And this is the half wave. So we simulate and run a PSIM simulator, run sim view, and we have to choose the VS and reload. Okay. So the source is as usual, sinusoidal signal, but the load, we can observe that the negative part of the source voltage is like blocked right here. It's blocked. See? So we can see that the SCR is only allow the positive cycles enter as output. Why? Because we know that SCR is something similar like diode, which they only allow forward bias current pass only. So since we're having AC source as an input, so the AC source will have a positive and a negative part. So when it's positive part or positive region or positive cycles, it will forward bias the SCR. When it's negative cycle, it will reverse bias the SCR. So this is why when we're having only single SCR, only the positive region or positive cycle of the signals can pass through or can be output, but the negative cycles cannot. So let us take a look at the data. So in this experiment, we can also observe that when our firing angle increase, the speed or the VDC or IDC or power will be decreased. It's happening the same if we apply the variables into the half wave. Why? Because firing angles is something like a delay angles. So whenever our circuit being delayed, we will like lose a proportion of signal entering the SCR. So it will cause a decrease of the speed in VDC and IDC and so on. So let us take a look. Choose. Okay. We simply find the circuit first, run it first. So if we're having the same circuit, if we're having a same circuit and the SCR having a delay angle right here, we know as firing angle which alpha. So when it's being delayed, only the signal after the delay angle will enter the SCR. So by mean that this proportion of signal will be lost, and only here after this will enter the SCR. So this is why when the firing angle is getting bigger, the values of the speed, the VDC, and so on will drops because we have already lost the proportions of a signal right there. And however, these situations will getting better, or how to say, it will increase back when the alpha, the firing angles, is at 180. So yep, this is all my presentation right here. And yeah, so thank you for patience on listening on my presentations. Thanks.